Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video I'm going to talk about a reworking that I did of my home lab and home network that I think might be useful for you if you're building your own home lab and want to have an idea of what I do for it. And then I like talking about some of the things that I'm working on just in my own time for my own learning and enjoyment of IT stuff. Before I dive in, I do want to thank returning subscribers for watching another video, as well as invite everyone, if you're watching and you haven't subscribed yet, to click the subscribe button and ring the bell when you do, so you can be notified of when new content comes available. So first, I am going to talk about the actual topology of the network. I'll talk about what I had before in my old apartment, and I'll talk about some of the changes that had to happen when I moved to a new apartment and as a result got a new ISP. Then after that, I'll go into some of the technical details, in particular about network configuration as far as how the traffic and such actually passes from VMs to the rest of the network and then back out to the internet. So I hope you enjoy it, and without further ado, let's get started. So I want to start out by drawing what the original topology was of my home network and home lab, and then from there we'll go into what changes I've made with this most recent refresh. So I have my ISP, which that was Comcast cable, which that would go to my cable modem. From the cable modem, I would go to my Ubiquity Edge Router Lite 3, which served me for many years. From the Edge Router Lite 3, I would go to a Ubiquity Edge, if I can spell that right, Switch 10XP. Now I chose that switch way back when for a couple of reasons. One, it has power over Ethernet, even though it is not enough PoE to power a VoIP phone. I had to get a PoE injector for that, but it was enough for the Ubiquity access point and such. Also, it is a fanless switch, and the Edge Router Lite 3 is also fanless. And so in my apartment, where I have one of my 2 bedrooms as my office, it's kind of nice to not be listening to a data center all day. Eventually, when I have a house, I'll try to have like a little telco closet where I can have some more powerful equipment and such. So everything else in my home network and home lab is connected to the edge switch. So I would have my Ubiquity WAP. I think I have the AC Lite Ubiquity WAP, and I would have a couple other things, my printer, and actually at the old apartment I had stuff set up to where I could actually run cables to PlayStation and TV and such, to where they could have wired connections. But the big thing for the lab was my Dell T420 server. Again, tower server, not nearly as loud as a rack server. So that had the connection to the switch. And then from here, everything, this is where the lab was run. I had VMs. One was a bind VM for DNS. I had a Unify controller for the Ubiquity stuff, and I would run some various other VMs. And the connectivity, I had the one of the NICs that's pretty much flowing all the traffic of the VMs, and I'll talk about the configuration about that a little bit later when I get into that piece of what's going on with the lab. Had another NIC that was the iDRAC connection. Apparently it is tough to write and talk at the same time. iDRAC connection, and that gave me kind of an out of band management for the Dell T420, which was especially useful when I made the videos about installing Hyper-V and making that environment. Since I'm installing that on the bare metal, I was using the iDRAC connection to manage the installation, which then I could do a screen capture on my my workstation machine to be able to do the video. And then there were some other bridges or virtual switches within the Dell T420 for some lab stuff that was siloed off of the rest of the network, and I'll talk about that a little bit later, but that's where I had my REL network, which is what I did my R8CE practice on and such. So this is pretty much the basic topology. If I were to change colors, go to green, I mean, all the traffic would flow to this Ubiquiti switch, which DNS requests would go to the bind VM, and then that bind VM would go back out the switch to the router, to the cable modem, to the internet, on and on and on. So that's the basic topology. And with my refresh, that is largely unchanged. What has changed is how the routing and such is handled. So let me clear my page here, go back to black, and so now my ISP is Google Fiber, which is awesome. That will be going away in about a year or so, but for right now it's Google Fiber. And the thing about this is I have a gigabit both directions, which is quite nice. With Comcast, I think I had like 100 down and 10 up, something like that. I can't remember off the top of my head. But the problem was with that connection, which, by the way, this goes to a fiber jack, which looks like a little telephone jack. Basically, in the apartment complex that I'm in, all of the apartments have the little fiber jack already installed, and so when you sign up for the Google Fiber service, what they did was basically send me the power supply for the fiber jack, and then from here I have Ethernet that would be going to the edge router light, and then again to the switch, and then to the tower, Dell T420, and that's basically how the network was, and that still had the same access point and such. The problem though was with the edge router light, at most I would get like 150 megabits for my connection, both in both directions, and that was kind of strange because the edge router light has gigabit ports on it, both for WAN and LAN, and so kind of the troubleshooting stuff I did with it, I actually ended up contacting Ubiquiti themselves about it, and the best solution is to turn on basically hardware offloading to where more of the routing calculations and such are actually being done by the chips on the hardware versus just being done within the Edge OS operating system, which that's probably a super oversimplification of what's going on, but basically I was getting more of the router hardware to do its job. And even then, even with turning that on, I think at most I got like 200 megabits per second, but clearly nowhere near the 1,000 megabits. And then if I took the router out of the picture and I connected, just my laptop with its gigabit NIC, even that, I mean, I would get close to the wire speed of 1,000. Obviously, I'm not going to get a full gigabit. You have Ethernet overhead and such, but the router was a choke point. Now, this wasn't necessarily a problem as far as, I was functioning fine with the internet connection I had from Comcast. But if I'm paying for Google Fiber, I would like to have, as close to that gigabit connection as possible. So at the time, I didn't really have the time to explore really other options for routing, and I did not want to spend the money on another router. I had some other obligations and such I wanted to get to. So what ended up happening was I replaced this with the router that Google will provide you for free, which is also a router and a wireless access point as well. And of course with this I have my full connection speed and everything function fine on the network. The problem with this, and this really isn't necessarily a technical problem, although there are some technical problems, but I don't like not having control over my entire LAN network as far as all of the devices having basically root access to them to do whatever configurations that I want and the like. And with the Google Wireless Access Point, I did not have that. Now I could go in and control a few of the DHCP settings and a couple of the WAN settings as far as whether WAN should be static IP or DHCP, and what DNS server the Google router itself uses for its forwarding. But that's about it. And I just that bothered me. I wanted to have my control back, especially in the fact that with this I could not configure internal DNS for this. Like the router itself was basically well, actually it wasn't a resolver. It was a forward and caching DNS to where it would send DNS up to Google and then cache the results for me. So I dealt with it. I don't have the control that I want, but that's all right. But eventually I did get the time to deal with this and gain control back over my network, which is what this refresh was. And so my options for dealing with this are I can either buy a router, which I would probably get the Edge router for. I would assume that it would be able to handle a gigabit connection simply because the hardware is basically 2 times better than what the Edge router Lite 3 had. Or I can use either a VM or another box, run Linux on it, and turn that into a router itself. So I'll just put Linux router here. And this option really intrigues me because there's some learning opportunities there. I have good understanding of networking, but I have not made my own router, which from a networking perspective, really all I would need to do is have it be able to do NAT and a couple of things, but still is something I haven't done before. So not necessarily wanting this little creation to be my production router because even though, it's my home lab, but it's also the router for my home network. And so if this goes down, we don't have internet access, which is a problem for me from a work perspective because I work from home. And of course, my girlfriend that lives with me would love to have, internet access herself. So I opted for plan B for this. And this is actually something I did when I still had a server and co-location. I have a VM running ViOS, which ViOS is the project from which Ubiquiti's Edge OS is derived. And so this gives me, pretty much total control over this because this will be a VM running ViOS, but it's running something that is designed to be a firewall and router versus me just taking generic Linux distribution like Fedora or Debian or something and turning it into a firewall or router. So here's what the topology looks like now. I want to erase the entire screen because there are still some things that are relevant. So now the fiber jack, let's see, let's do this. Let me erase this little piece here. So we still have the edge switch. I know, terrible handwriting, but I'm just drawing some stuff out. And I have my Dell T420. And I have the Ubiquiti WAP. All right, so now here's what happens. The fiber jack is actually connected to a NIC that is on my Dell T420. And again, I'm going to go into the actual configuration of this stuff a little bit later, but I'm just kind of giving you the picture overview. And this NIC is sending its traffic to a ViOS VM. Then I have a second NIC on the Dell T420 that is sending the traffic, from all of the VMs to the edge switch. So I also still have a bind VM and the Unify controller and such. So that traffic gets into here and that goes to the edge switch. And I actually have a third NIC that is connected to the edge switch, which is actually the T420's traffic itself. And I'll explain a little bit later why that is the way it is. And then of course from the edge switch, I have the wireless access point and the other devices. So the way traffic would now flow, I'm going to change to green. Let's say another device needs to access the internet. It would send its traffic to the edge switch, which it would then send its traffic over this link to bind, of which bind will send its traffic to ViOS, which will send its traffic out this other NIC to the fiber jack, which sends the traffic to the ISP. So basically what I've done is replaced the router that would be here with the ViOS VM. And so what this is giving me is the gigabit speed, of course, not quite a gigabit because of overhead, and I have total control over my router again, and life is generally good for my network, and I'm able to do the things that I want. Okay, so you've seen the layout of the new home lab network. I'm going to show you some of the technical details about it as well. So I have one is actually an explanation of VTAP, which I'll share with you. But if you take a look at what I have here with Virtual Machine Manager, the VMs that are home dash are my quote production VMs. And I say quote because this all is a home lab, but I have some things that are really the foundation of what makes my just home network function. And then there will be other things that are truly just spin it up, mess around with it. If it breaks, it doesn't hurt anything, and then and let that be it. But you see I have my VIOS VM, I have bind. Ansible is a work in progress. I eventually want to control anything with home using Ansible. That's my unified controller, and these are a couple of one-off things that if I need to have a quick Fedora server or Fedora workstation that has nothing installed other than just being updated to the latest packages, that's what those VMs serve. Now, as far as the networking for this, if I were to look at my bind server here and go into details, you're going to see that pretty much all of these VMs are Mac VTAP, and the device name that's being used is this particular one here. So here's my actual KVM host. If I were to do nmcli con show, this is one of the NICs that's on the server. The server actually has 4 NICs, 2 that are on board and then 2 that are on an expansion card. And so the way Mac VTAP works is it is allowing the VM basically to send traffic over that physical NIC directly. And so here, this is actually from the RHEL 7 documentation, and this might be mice type on your screen. Let me zoom this just a bit. So I know my resolution on my monitor is greater than that of what I output for OBS. But there are 3 basic modes for Mac VTAP. And Mac VTAP is actually a network driver that makes the bridging aspect of doing VMs a little bit more simple to use than actually making a bridge itself. VPA is what it does by default, but I have never actually used this on any type of production thing. Mainly it is because of it would basically send, as you can see in the diagram here, all traffic, even VM to VM traffic, to your external switch and back. And so your external switch has to be able to support something called hairpin mode. And I know the switch that I have doesn't have that. And plus, I can't really think outside of maybe you want to have this external switch with a port that all traffic is mirrored to it for some type of monitoring purpose and such. I wouldn't want all of my VM traffic to always go out to the switch, especially if it's VM to VM traffic. So what all my Mac VTAPs are configured as are with bridge mode. And so that way traffic, if it needs to go to the external switch, it can, but traffic that goes between the VMs is done within the physical interface that they're bound to with the Mac VTAP driver. Then of course, private mode, nothing can really talk to one another. So the one downside to using Mac VTAP, and this, if I were to go back to my VMs here, and let me open up VM that's off. We'll go to the details and let's add another NIC. Actually, it has the warning here. It says most configurations Mac VTAP does not work for hosts to guest network communication, which means that under the configuration that I have right now, which is this one NIC via Mac VTAP, is allowing the traffic from my VMs to get to the switch, and then that same Mac VTAP will allow the VMs to talk to the VIOS VM, which is my router. The host won't be able to talk over that Mac VTAP to the VMs. And there's a couple of ways to handle this. What I chose to do, EN01 is one of my physical interfaces. So if I were to do IP adder show EN01, this has an IP address. And so since I have multiple NICs available, I just dedicated a NIC for the host to communicate to the rest of the network. And since this traffic would be going to the switch itself, that traffic can get back to the ViOS VM and the bind VM. Go back to the Vert Manager, the ViOS VM to get out to the internet, and then the bind VM for network lookups. Now, there was a third piece for the configuration that I mentioned, talking about topology, and that was for the ViOS VM itself. So let me bring it up. And let's take a look. Actually, I'll do it via command line. That might look kind of cooler. All right, so let's do versh dom. I think it's dom, not dom name. Let's see. What do I want? If list. That's it. So home ViOS. And notice that it has two MAC-VTAP interfaces. And the EN02, this is actually connected to the fiber jack. And so the IP address that is on the what's basically WAN interface 0 on my ViOS actually has a publicly routable IP address, because EN02, as you can see, is not really an active interface. If I were to do IP adder show EN02 or O2 actually, you will see that the link itself is up, but it does not have an IP address because its sole job is just sending traffic to the ViOS VM. And then it has another MAC-VTAP interface, which this is that same interface that all the other VMs are using to be able to talk to the switch. And so that way, other things on my network, such as the wireless access point and a couple other things connected to the switch, they have a way of getting to the ViOS VM as the router to get out to the outside world. The one other configuration thing I wanted to talk about were a couple of the other virtual networks. So if I go to my connection details and virtual networks, you will see that I have a few virtual networks that are already configured. The first of which is the default virtual network, which this is going to be in pretty much every KVM installation. And if there's some type of one-off thing that I need, this is what I will connect the VM to. It is using bridge 0 that's created, and bridge 0 will forward, I believe, to any of my interfaces, and it does that via NAT. So this network can access the internet because basically it will NAT to the physical interface. The thing I'm curious about, let me look at IP link VRBR0. Did I spell that right? Just do IP link grep VIR. There it is. I can't think off the top of my head how to look at what's connected to the bridge. Oh well, that'll be something I might do in a later video. But basically, traffic that comes to this virtual network is going to be natted to whatever the IP address is on the interface that it would be sending traffic out the VM to, which is probably going to be EN01, because it actually does have an IP address on the local network. The thing is, anything on my local network, which that network is 192.168.1.0, stuff on that network cannot talk to these VMs here. It would be sending the traffic to the ViOS box, and the ViOS box is not going to know where to route that next traffic to, since none of the NICs on the ViOS box connect to this virtual network here. Now the test rel and test win, there's nothing on the test win network right now, but the test rel network is where I had all of my RHCE practice stuff. And so what I use this for is to have a network that would be able to have internet access, but again, nothing on the home LAN can touch it, nor can it touch. Actually, I think it might be able to touch stuff on the home LAN. Not 100% sure of that, and frankly, there was nothing that it ever needed to touch on the home LAN, so it wasn't an issue. But notice what I have here. When you create the virtual network, you can choose not to allow DHCP to be used, because these virtual networks use DNS mask to provide DNS forwarding and DHCP services. Rather, for both of these networks, I have that disabled. There is still a default gateway. And actually, I think I may be able to show it here. see if I can find it. Yeah, so bridge 1 has an IP address that's 192.168.10.1, so that's effectively the gateway for this virtual network, which then gets natted out to a physical interface. But I actually have a VM that would be on this network that is going to provide DHCP and DNS services, so that way I can have a kind of a full functioning little mini network inside of my general home lab network that I can do for various things. So I felt like I rambled on just a bit, and hopefully it wasn't too bad. I can kind of talk about my home network and home lab forever, even if there's not a whole lot of stuff with it. I can still just go on and on about it. There's nothing real special about it now with the refresh, other than the fact that I've changed from using actual physical router to the software router with the VM. But I will be expanding on this lab, and as I do it, I'll make some videos about what I'm doing, so kind of show off what I do, as well as if you're wanting to do some of the same things, my videos might be helpful for you as far as your own building of your home lab. I do want to thank you for taking the time to watch. I want to thank returning subscribers again for watching another video. And if you haven't subscribed, click that subscribe button and ring the bell. If you enjoyed the video, make sure you do click like and feel free to share it with others. Also, feel free to leave comments. I'm curious to hear about what you yourself are doing with your home lab, and what your topology is, and what equipment and such you use, because you might give me some ideas of things to do with my own lab. Again, thanks for taking the time to watch, and I'll see you the next time.